Hello there and welcome to Logic Gates. So today I'm going to talk to you about logic gates, why we use them, and take you through the kind of gates that you need to recognize and how they behave. So what is a logic gate? So a logic gate performs logical functions, and they are really the building blocks of all circuits. So if you looked inside a CPU, you would find hundreds upon thousands upon millions of these things used to basically to do with the signals and how certain inputs can cause certain outputs. They're switches essentially, but without them we just wouldn't be able to have modern circuitry. The objectives today are here. I won't read through them all. You can pause the video and just have a scan through. A lot of this won't mean too much at this stage, but I would invite you to revisit them after you finish the lesson to ensure you understand all of these key objectives. So let's look at our gates. There are three major gates that you need to know. The first one is called the AND gate. Now it looks like a big capital D, so a little way to remember this one is the word AND. The big letter D on the end of AND looks very much like the gate looks if you were to draw it as a diagram. Now AND gates can have two or more inputs, but all gates will have one output. So if we were to have some kind of input coming in here, and because we're talking about computers only know binary, that's on or off, that's 1 or 0. If there was an input coming in on this line and an input coming on this line, then the output would also be on. A good way to think of it would be like a two-stage kind of switch on some kind of device. So you had to have both switches on for the device to be on. So when I start my car in the morning, I have to fully press down my clutch pedal, that would be like A being on, and I then have to press the ignition button, that might be B being on. If I press either or on their own, it's not coming on, but when both are pressed, it's coming on. So this is the way it behaves. Now up here is the truth table, which is showing whether the inputs are on or off and what is happening here. So we call this a truth table. So when both are off, the AND gate is off. When one of them is on, it's still off. When the other one is on, it's still off. But when we have a condition where both of them are on, then this gate is triggered on. So that is the AND gate and how it behaves. So now I'm going to get you to build that in a nice website called logic.ly. So we're going to need to go to logic.ly. It looks a bit like this. So on this site, you go to logic.ly, as you can see at the top here, and you're going to want to click free trial. You'll also see then here this link, try logically in your browser. Don't click these because this would install something. Click here. You'll then get this. You can close this straight away, and we've now got some things which we're going to recognize, particularly our AND gate. So you can drag out the AND gate. You could drag out a couple of switches like this. You could then drag in a light bulb, which can be our output, and then we can start to connect these together. So here's our two switches there, there's that, and we've made a simple AND circuit with two switches. You'll see if I switch on A, nothing. If I switch on B, nothing. But if I switch on both, hey presto, we have a light bulb. So what I'd get you to do now is pause the video here and build this circuit and make sure you've got it working before you continue. So have a go at that first. Okay, so our next gate is called OR. Now the OR gate behaves a little bit differently. It will trigger if any of its inputs are on. So here in the example, if I have both of them off, this is the time the OR gate is still off. If I have one of them on, it is on. If the other comes on, it is on. Question is, what happens if they're both on? And a lot of people would guess this incorrectly because they think the word OR means one or the other. But in this case, OR will come on if any come on. So because any of them are on, and that means, well, both of them are on, that means it's on. So you can think of this as a light switch with two switches, and either of them is going to trigger the light switch. So let's take a look at that in logic.ly. So we go back to our circuit here. I'm going to get rid of this gate now, which I can delete by right clicking it, and I'm going to just change it for an OR gate. I'm going to just slide in the connections like so, connect it up, and now you can see it's on because I've left my switches on. But if I turn both switches off, it is off. Turn one on, it's on. Turn the other on, it's on. Turn both on, it's on. And that's how an OR gate behaves. So have a go at building that one. You can do it underneath, or you can replace it like I did. And pause your video now and have a go at that, please. Okay, so you should be back, and we're going to look at the last gate you need to know about. This is called logic NOT. Now the NOT gate, like its name kind of suggests, does the opposite of what's going on. It only ever has one input. The other gates can have several, but in this case, this gate will just switch what's going on. So it looks like a triangle. You'll notice that the OR gate looked a bit like a squashed kind of letter D with a curved back, and that's the one you need to remember. Really, that's the hardest to remember. But with this NOT gate, if you've got nothing coming in, then it will trigger an on output. If you've got a signal coming in, it will then trigger an off output. So it kind of inverts what's happening, and that's what's important to remember with this gate. So let's have a look at that in logic.ly. So if we come in here, we only need one input for this one, so I'm just going to build a quick new circuit, get our NOT gate here, get a new light bulb, and when I connect this together, you can probably predict, because it's already off, that when I connect this together, psh, on comes the light. If I flick the switch, the on becomes an off, so it's kind of an inverter. Alright, now those of you that ever played Minecraft would have maybe messed around with redstone before, particularly the redstone torches, and quite often you'd place these little torches on the side of blocks or on top of blocks with switches nearby, and you've probably, without even knowing it, made one of these gates, whether it be a NOT inverter gate or perhaps an OR gate or an AND gate. So pause the video now and ensure that you've built the NOT gate, and then you'll have built all three of the primary gates. So do that now. Okay, so there's our three gates. That's what they look like. Remember what they look like. You need to be able to identify them by sight, and you need to know how they behave, as in the truth tables of all three, when they come off and when they go on. Quick task for you. I want you to go to logic.ly, and I want you to build the gates but with three inputs. I'll just show you how you can tell logic.ly to do that. So if you go into logic.ly and you grab any of these gates, so this gate here, you'll see down in the corner, you probably can't quite see, there it is there, down in the corner you'll see the count of inputs, and you can increase that to 3. So if you do that for both the gates, you can then connect it up together. What I'd like you to do, going back to the slides, is I'd like you to build those gates and then predict almost, so if I just go to the next slide, I want you to predict then what you think's going to happen when now we have 3 inputs, so you can see the truth tables bigger, because these are all the different combinations you can have of these 3 things being on and off. I'd like you to predict, without building them first, what you think the outcome will be. Once you've had a guess, so you can sketch this on your whiteboards that you have, or you can get a piece of paper and write it down. I only want the hidden bit, you don't need to do the whole table. Once you've had a guess, I want you to then build it in logic.ly and then see what the result is. Pause the video now and have a go at that task. Make sure you understand what you're being asked to do before you do so, and then when you have done and you've got your full result, then continue to watch the video and see if your results match up with the real results. Do that now. Okay, so here's the results. So we can see in the first case, like the AND gate, you would hope you'd have predicted this. It's only coming on if all 3 of those inputs are on. Okay, and with the OR gate, any instance where any of these are on or several are on are going to cause it to be on. So we should have got a situation where it's nearly on all the time except for the time where all 3 are off. Now sometimes you can have multiple gates connected together like we've got here. So we've got a not inverted on this AND input. I'd like you again to repeat that process of having a guess as to what this will do, and when you've had a good guess and you've jotted down what you think is here, build the circuit in logic.ly and test to see if you're right. Pause the video and have a go at that now. Build this and predict what this does. Do not hit the switches in logic.ly until you've had a go at thinking what it might be first. Off you go, have a go at that now. Okay, so this is the result you should have got. The only time this is coming on is when A is on and B is off, because the not will then switch it to on, so they're both on then. So the only case in which where this gate's going to trigger on is when A is on and B is off. So you should have got that as your answer. Have a look at a slightly bigger, more complex problem. Here you go. So work this one out through, first on a whiteboard or on some paper. Once you've had a go and you think you've got a result, build it in logic.ly and then see if your answer is correct. Pause the video now and have a go at that task. Okay, so here's the results then. So this is going to come on if C is ever on. Because this is an OR gate, C will always trigger it. So the easiest thing to do is to go down the column of C, and wherever C is on, then Y will be on, so the output will be on. The only other time this gate will be on is if A and B are on. And there's only 2 times that happens. Well, we already know it's on when C's on, but this one here where C is off, it will be on because A and B are on. So there's the final pattern for you, and hopefully you got that. If not, do go back over it again and make sure you understand. Some extensions which you can look at. There are some kind of special gates, and what I'd invite you to do now is to try and figure out their behavior and then discuss that with the teacher, whether that be in class or if this is remote learning via some kind of chat. I'll show you the gates locations in logic.ly, and then you try and hook them up together and see how they're behaving and why they're a little bit different to the other gates that you know. So in logic.ly, what you can see is we've got the NOR gate, the NAND gate here, and we've got XOR gates. I'd like you to kind of string them together and figure out why they're a little bit different and what they might be doing compared to the other gates. Okay? So, going back to here, I'm particularly after, by the way, what the X or N actually stands for. So if you can kind of figure out what you think that stands for, that'll be interesting. That's a conversation you can have with the teacher in the lesson. So we've gone through those gates. I would ask you at this point to probably have a pause and maybe have a think about, and I apologise that my background keeps going out, but there's nothing I can do about it. I would like you to have a look at why you think these things are really used. I've already kind of had a little bit of a chat at the start of the video to kind of say that they're needed, but have a little research task, maybe have a couple of minutes and see the kind of things logic gates are used for and why we need them, and what do you think would happen if we didn't. Now, the following activities that are available are stretch-based activities. Now, they won't be in the video for now, but the PowerPoint will be available in class and also available via MS Teams. But for today, I'm going to leave it there because that's the basics of logic gates. The rest moves on to Boolean algebra and the more kind of advanced aspects, which are definitely seen in the GCSE and would fully equip you. Stuff you've already done is GCSE content, so well done for getting your heads around that. But until next time, thanks for your attention, and I hope that you've learned something new today. Take care.